Alright, we are to derivative of a function. This is Notecard 9, and this goes through our limit definition of a derivative. So for this first part, we go through once more and we look at our difference quotient, and we need to look at this limit as h approaches 0. And remember that h was the distance between our 2 points of our secant line, and f of x plus h minus f of x all over h. Now, keep in mind we call this our slope generator, and that's because when we're looking at these functions, you're going to have several different tangent lines, and we need to find the slopes of those tangent lines. Now, it's something that we did talk about in class, this minus f of x. Behind this last subtraction sign, this f of x, this is going to be where we look to find our original function. And it's important for us to be able to pick out that original function. Now, graphically, the derivative of a function at a point P is the slope of the tangent line to the graph of f at P. That's important for us to know. Numerically, the derivative at a point is the limit of slopes of the secant lines, or the limit of the difference quotient. This is our difference quotient, f of x plus h minus f of x all over h. Now, number 4 we've not talked about much in class. The derivative at a point x equals a is found by. Now notice the only difference here in this part and this part up here, we've replaced our x with an actual numeric value. That's why it's called at a point x equals a. We have that different value. Or notice that this limit can be x is approaching a of f of x minus f of a over x minus a. So there's another way to look at this. So our derivative, our limit definition of a derivative, here's the first definition that we looked at. Now this number 4, the only difference between the first part of number 4 and what we have been looking at is that we've replaced x with a known value. And then this part over here, the limit as x approaches a of f of x minus f of a over x minus a. This again is just another way to state the derivative at a point x equals a. Now let's look at this first example that they've given us. For f of x equals negative 5x plus 4, use the definition of a derivative to find. In the first part, a is f prime of x, and then b f prime of 2. So if we use our limit definition of a derivative, remember that's our limit as h approaches 0 of f of x plus h minus f of x, and all of that is over h. This is going to give me my f prime of x. So notice my f of x is negative 5x plus 4. So for my a part, to do f prime of x, I need our limit as h approaches 0 of f of x plus h. So everywhere I see an x, I'm going to put x plus h. So I have negative 5 times x plus h, and then plus 4. And then I need minus f of x, which is negative 5x plus 4. And every bit of that is over h. Okay, now we need to simplify some of this algebra through here. So let's see what we can do with that. We have our limit as h approaches 0, and that's going to give us negative 5x minus 5h, and then we have our plus 4. Distribute our negative, we have plus 5x minus 4, and all of this is over h. And then again, I'm sure we can collect some like terms here. So we have here it looks like our negative 5x and positive 5x should cancel. Positive 4 and negative 4 should cancel. And so notice I'm left with a negative 5h over positive h, and then those h's should cancel. So that means that my limit as h approaches 0, well, once I clean up all this, it looks like I'm left with negative 5. And so my limit value should be negative 5. Or remember, we were talking about f prime of x, so f prime of x should be equal to negative 5. Well, if we think about the graph of this, this is a line. This is the graph of a line. So if this is a line, the linear, we have a constant slope. And notice with our constant slope, our slope is found right here. It's negative 5. So even though we went through our limit definition, we could have found our slope if we realized that the derivative is talking about slope. Our slope is sitting right here at negative 5. So f prime of 2, no matter where I'm at on that line, no matter what my x value is, the slope of that line should still be negative 5. So the b part here is negative 5. Right, moving on, let's look at number 2. We're asked to evaluate, and gracious, this is a mess here. But notice we have 6 times x plus h minus 2 times x plus h plus 7. Now if we look and inspect every little part that we have here, notice this is asking for a derivative. We're looking for f prime of x. So if we knew what our original function was, and since we've already talked about the power rule, if we know where this original function is, then finding f prime of x should not be that difficult. So from here, notice that our original function is sitting past that very last subtraction sign. And again, I'm getting that from up here, right here, that limit definition. Notice this is the difference quotient, and the last part of this is minus f of x. So coming back down here, notice my f of x is sitting right here, 6x squared minus 2x plus 7. So now that I know the power rule, f prime of x, we're just going to go through and do the power rule for this. So that means I'm going to have 2 times 6x to the 2 minus 1 minus 2 times, and the exponent here is 1 x to the 1 minus 1 plus, now this 7, this is really an x to the 0, there's not one there, and if I multiply that through, that's just going to be 7 times 0, so really that derivative should go to 0. So f prime of x, once we simplify all this, is going to be 12x minus 2. And if we worked out all of this and went through and multiplied all this out and distributed, we would have ended up with this same slope generator or derivative value. Right, looking at number 3. Number 3 was from an AP exam. That's what the asterisk means. And here, be very careful. It's very tempting to say, oh, this is asking for the limit, or this is the limit definition of the derivative at a particular point. Let's be careful about assuming such. I don't think that's what this one's asking. When in doubt, plug in and see. So we have the limit as x approaches 0, and notice where we have f of x minus f of 0 all over x squared. So let's see what that's going to be. So I have the limit as x approaches 0, and we're going to have our f of x, so we have 2x squared plus 1, so there's my f of x, minus f of 0. So I'm going to come over here and say, well, what does f of 0 look like? Well, f of 0 is going to be 2 times 0 squared plus 1. So it looks like I'm going to have a 1 here. And that's all over x squared. So this is going to be our limit as x approaches 0. And if we simplify here, those ones will cancel each other out. And I have 2x squared over x squared. And then those x squares should cancel. So my solution here is 2. So all of this would simplify to be 2. Right, now let's look at number 4. Number 4 wants us to figure out which one of these two is equal to f prime of 4. Now this time we're asked for the value of the derivative when x equals 4. That's what this is asking for. So let's go back up and see. That's going to be number 4 here from the very top, and let's investigate this very first part. That's the limit as h approaches 0 of f of a plus h minus f of a. So notice from our original, x has been replaced with an a value. So down here I need to look and see, well, which one of these two on number 4 has our x value been replaced with 4. And notice very quickly over here at number 2, x is still inside the problem. So this one cannot be correct. So my answer choice here would have to be 1.